Hello again, and thanks for sticking with me through these lectures on organic chemistry and using the Klein Organic Chemistry textbook. Today we're going to be jumping into Chapter 18, aromatic compounds. So let's take a look here at some substances. Benzene is the simplest of all aromatic compounds. It has a formula of C6H6, and it's simply just a phenyl ring there with nothing attached. So it's 6 carbons and 6 hydrogens. Now, when you have a benzene ring in a compound, we call that a phenyl ring, okay? And this is highlighted in yellow down here. Now, aromatic compounds were traditionally isolated from saps from trees and bushes, and they had spicy and beautiful aromatic flavors and odors. So they call these substances aromatic compounds. But we now have extended this to many compounds that have completely no odor at all. But anyway, here's some examples of some spices down here. Eugenol is from cloves, and you can see how it has an aromatic ring highlighted in yellow. Cinnamic acid is found in cinnamon and other plants. And this compound called thymol is from thyme oil. So that's used in cooking sometimes. Now, there are many common aromatic names that were developed long before IUPAC came along and said, look, this is getting out of hand. Let's name these things systematically. And the Klein's Organic Chemistry textbook even says here, and I quote, "You must commit these names to memory as they will be used extensively throughout the remaining chapters." And I'm online with that. I think we should memorize these. So if you want, you can make flashcards of these and commit these to memories. So if we have a methyl group attached to the benzene, we don't call it methylbenzene. It's commonly called toluene. Okay. If you have an OH attached to the aromatic ring, we call this phenol. And we've thus learned about phenols and how they're more acidic, and the functional group phenol is the OH or the hydroxyl group attached to that. This is called anisole. This one is called aniline. It's a component used to make a lot of dyes. This is benzoic acid. This is benzaldehyde. All right, so this next compound here is acetophenone. And this last structure is called styrene. Okay. All right, so you'll just have to remember those. So if we're talking about chloroaniline, you might know chloro, but you might not know what aniline is. So you need to memorize aniline, for example, so that you could know, oh, there's a chlorine on the ring somewhere on that molecule, okay? Now we have 3 different isomers when we're talking about aromatic compounds. So let's just use chlorine as an example. If we just have a chlorine atom attached to a benzene ring, we call that chlorobenzene. And it doesn't matter where we put the chlorine atom because it's always just going to be at an arbitrary atom number 1. So we don't call this 1-chlorobenzene. Now, if you have dichlorobenzene, you have 3 potential isomers. So I'll draw 3 phenyl rings out here. And then I'll attach 2 chlorines on 2 different carbon atoms. So there's 2 different ways of naming this. Now, if you just have only 2 substituents on the aromatic ring, it doesn't matter if they're the same or different. You can number them out. So this could be called 1,2-dichlorobenzene. When you have 2 groups that are adjacent to one another, this is called the ortho isomer. And so a synonym of this name is ortho-dichlorobenzene or just O-dichlorobenzene. So if you see O with a hyphen, that's what that O means. It means ortho. This middle one here is meta. So if you have two groups that are at positions 1 and 3, they have a meta relationship to themselves. Okay. So, you know, obviously we could call this 1,3-dichlorobenzene. Or alternatively, we could call it meta-dichlorobenzene, and we abbreviate meta as a lowercase m. This last one here is a para-isomer. Okay, P for short. And so we could name this para-dichlorobenzene. Okay, or 1,4-dichlorobenzene. So ortho, meta, and para are the 1,2, 1,3, and 1,4 isomers of a disubstituted benzene. Now, if you have a benzene ring that has 3 different things on it, we can't simply call it, meta something or para something or ortho something, because actually it's all 3, right? So in this case, if you have a tri-substituted aromatic ring, you would have to name it 1,3,4 trichlorobenzene, okay? So when you have only 2 groups present, you can name it as an ortho, meta, or para isomer. And we're going to use this nomenclature a lot when we talk about reactions of monosubstituted benzenes, okay? Now, for naming aromatic compounds, the process is much similar to other things that we've learned in the class. You identify and name the parent, but be careful, the parent could be very complicated, okay? So the step 1 is to ID the parent. All right, so if you have something like this, the parent is going to be benzene because that has 6 carbons, and the group off to the side there only has 3. So the parent here is benzene, and this would be called propylbenzene, okay? Now, if you have a parent that contains one of these specially named common names that we saw before, you have to identify the parent, okay? So we're not going to identify the parent as benzene. That could be a possibility, but what I would rather do here and what is recommended is that you select phenol as the parent because that's one of the common ones that you've memorized before. So the parent here would be phenol, okay? And when you identify the parent as phenol, the attachment of the special group, in this case the hydroxyl group, is assumed to be at carbon 1, okay? So we could name this 3-chlorophenol, or as we saw before, we could name it meta-chlorophenol. Okay, so memorize those common names, and those sometimes will be the parent compound, okay? Now, when you have a substance like this, it could be debatable whether you select toluene as the parent group, which is a common name, or anisole, which is the parent name, which is the common name. And I don't think anybody's going to debate you on that and give you such a tricky problem. So you could name this methyl anisole, or you could name this methoxytoluene. Either of those are going to be acceptable names in my book, okay? Either way, make sure you put ortho such and such at the end of this, okay? Now, after you identify and name the parent, You need to identify and name the substituents as usual: chloro, bromo, methyl, phenol, something like that. And then you number the location of those substituents, and then you assemble the name alphabetically. So your typical substituents that we'll see in organic chemistry are hydroxy groups sometimes. Usually it's just a phenol, so we don't need to worry about that. Halogens we've seen before: chloro, bromo, iodo. Okay. Alkyl groups, we're well versed on that: methyl, ethyl, propyl, even a cyclobutyl or cycloalkane groups. Now something new for you might be the nitro group. This is going to show up quite a bit. Okay, nitro is a very commonly occurring group there. Okay, you might also see a trifluoromethyl. Okay, that's going to show up quite a bit, and we'll see some sulfonic acid groups and some other things in a little bit of time. Okay, but let's go through some examples here and then look at some problems. Okay, so how would I name this compound? First, we find the parent compound. The parent compound is going to be benzoic acid. So again, we assume that carbon 1 is where that carboxylic acid functional group is bound. And then out here at the para position, we have a methyl group. So this is going to be called para-methyl benzoic acid. Okay. My tip is unscrewing there from my pencil. All right. Now how about this? All right. So we have this structure here, and you need to identify the parent compound. Here again, I'm choosing something other than just benzene so we can reinforce some of those common names. This right here is called aniline. So this is the parent compound here, okay? And we assume that carbon 1 is where the nitrogen is bonded. So we have a chloro at the 2 group, and we have an ethyl at the 4 group. Now, since we have a tri-substituted benzene derivative, we cannot use ortho, meta, or para. We have to use numberings, okay? So we're gonna have, and we're gonna alphabetize this, okay? So chloro comes first, ethyl comes next, and then this is an aniline derivative, so we name it aniline. Okay, so that would be the name there. All right. So let's do problem 18.1. Asks us to provide a common name, a systematic name for each of the following compounds. So we need to identify the parent structure here, and that's going to be the one that contains the benzene ring, right? Of course. And then we want to look for something that we're supposed to memorize. We're supposed to memorize the one with the aldehyde off to the side, and that's called benzaldehyde. This is a meta-isomer, so it's going to be called meta-isopropyl benzaldehyde. Okay. Our next molecule here, we have part B. We have a methyl group attached to the benzene ring, and the common name for that is toluene. Okay, so toluene. And we have a ortho isomer. So the name of this would be ortho-bromo toluene. Okay. Our next molecule in part C has an OH, or a hydroxyl group, attached to the benzene ring. So the common name there is phenol. We don't have only 2 groups attached to the ring. We have 3 total groups, so we can't use ortho, meta, or para. For this, we need to number the carbons, and remember that carbon 1 is where the hydroxyl group is. Okay? As I mentioned, the NO2 group is called nitro. And you should be able to draw a Lewis structure, draw resonance, and know what that means. But for now, let's just call it a nitro. Sometimes it's written O2N, or it's written NO2. Same thing, all right? So this is going to be 2, 4, dinitro. And the parent name here is phenol. Okay, phenol. Our next molecule here in part D has no common root. That's a special name that we're supposed to memorize. It looks like just benzene to me. Okay. And we have 3 groups attached to this. So again, we're going to use numbers. We have an isopropyl group. We have an isopropyl group. And we have an ethyl group. Okay. Now, before alphabetization, the very first thing you want to do is start numbering things. And you want to position everything at the lower numbering, right? So we want this to be 1, 2, 3, 4. That's going to be the best way to position things at the lowest numbers. So it's going to be alphabetized next, at the end, at the last. So E comes before I. So I would name this 2-ethyl. Okay, so E comes before I, so that's why I'm doing that. And then we have 1,4. Now we have 2 of the same groups, which are isopropyl groups, so we use the prefix di there. Di, isopropyl, and we end the name with benzene. Okay. Molecule E looks like very complicated, but such hexa-substituted benzene rings are quite commonly occurring, actually. And you'll notice that that's the common parent. It's called phenol. And because that's phenol, we need to number the hydroxycarbon number 1. Okay, I'll change to a darker pen so you can see that, number 1 right there. We have 2 choices. We could number it clockwise or counterclockwise, okay? We want to number this counterclockwise because we'll get to the ethyl before the isopropyl, and that'll break the tie, okay? So when you have a substituent at all 6 carbons, you want to number in the way to break the tie of the other way, which has 6 substituents on all 6 carbons, by using alphabetization, okay? So we want to number it this way, so we would have an ethyl at carbon 3, okay? So we've got bromos at carbons 2 and 6. We have a chloro at carbon 4. We have an ethyl group at carbon 3, and we have an isopropyl group at carbon 5. So I'm listing them out here vertically in a column so I can alphabetize more easily. So it's going to be 2,6, dibromo, and then we have chloro, I believe, 4 chloro, and then we have 3 ethyl, and this hyphen is a, you know, like an end of line hyphen, and then 5 isopropyl, and highlighted in yellow is the phenol parent compound. Okay, so those are some activities. This was problem 18.1 in the textbook, and so I hope this gets you started on naming some simple organic aromatic compounds. Thanks for watching.